Let's put some of what we've learned to use in solving a simple problem. While driving along a highway at constant speed v, fast Frida sneezes and her eyes shut for a brief time t. Write an equation for the distance Frida travels while her eyes are shut. How do you begin to solve such a problem, or most any physics problem? Well, here's how I do it. I write d equals. That's right, I focus on what I'm asked for. In this problem, it's distance, so writing d equals gets me started, often the hard part. I can get distance from the basic equation v equals d over t. From v equals d over t, I rearrange it to read d equals vt. In fact, that's the solution to this problem. The equation tells us that the distance traveled while her eyes are shut is the average speed of the car multiplied by the time during which her eyes are shut. Let's put some numbers in here. Calculate the distance in meters that Frida travels during her sneeze, given that her highway speed is 100 kilometers per hour and her eyes are shut for 0.70 seconds. That's 70 hundredths of a second. Here we're asked to find the distance d in meters, while speed is given in kilometers per hour. Our task is to convert 100 kilometers per hour to meters per second. We use a process called unit conversion. We set up conversion factors so that the kilometers and hours cancel, leaving us with the units meters per second. The conversion factors we need are 1 hour equals 3,600 seconds. 1 kilometer equals 1,000 meters. Conversion factors have a numerical value of 1, like 1,000 meters divided by 1 kilometer, or 1 hour divided by 3,600 seconds, each equal 1 in magnitude. So multiplying a quantity by 1 successively doesn't change the quantity, only its units. So we say 100 kilometers per hour times 1,000 meters. What do I put in the denominator? Do you see it's 1 kilometer? If so, good. Let's continue. Then we multiply it by a conversion to change the unit hour to second. That's 1 hour divided by what? Do you see it's 3,600 seconds? If so, you've got it. Let's continue. Then we see it's 27.8 meters per second. That's her speed in meters per second. Our calculator tells us that the distance covered is 27.8 meters per second times 0.70 seconds equals 19.5 meters. Unit conversion is a powerful tool. Suppose our problem asked for the distance traveled in feet instead of meters. Let's suppose the conversion factor we know is that 2.54 centimeters equal 1 inch. Then we'd modify our conversion a bit. We'd add 100 centimeters over 1 meter. As we move to our knowledge of 1 inch equals 2.54 centimeters, continuing, 1 inch divided by 2.54 centimeters times 1 foot over 12 inches. And using our calculator, we get 91 feet per second. So the distance traveled in feet is 91 feet per second times 0.70 seconds equals 63.8 feet. Or we could have just converted 19.5 meters, our original distance traveled, to feet. See how the conversion factors clear unwanted units? They nicely cancel. So you know whether to multiply or divide with your calculator. Units guide the process. And we see that we get the same answer, 63.8 feet. That's yum. I want to leave you with a question. If fast Frida closed her eyes for twice as long as 7/100ths of a second, how much farther in distance would she travel at the same 100 km/h speed? Maybe you can use an equation to guide your thinking? Until next time, good energy.